Hello. Today, let's look at channel capacity. Channel channel refer to a channel through which information is transmitted. Uh, you are watching the video I am delivering today. This is possible because there is a channel between you and me. Channel capacity indicate how much information can be delivered through that channel. The limit to which information can be conveyed. As the wireless communication network evolves to 3G, 4G, 5G, channel capacities are gradually increasing. How can this is expressed mathematically? Shannon was the first to pioneer this field. In the in this paper published by Shannon in 1948, digital communication began. The formula I will explain today is the formula from this paper. Communication means to transmit the signal from one place to another in special terms. This includes wireless communication network like 5G and broadcasting like TV or radio. It also includes receiving signals generated inside the human body, such as ECG and CT from the outside. Communication also includes storing it in the present and viewing it in the future. The goal of communication is transparency. In other words, the goal is to appear as there is no communication, even though there is a communication system. But what hinders transparency? Many cattle are brought in Africa, brought up. However, the lion attack and eat cattle, which is much headache. So someone came up with an idea. They draw eyes on the cow's ass. They are experimented with thousands of cows in 3 years. Surprisingly, none of the 683 cows are attacked by a lion when they had eyes on the ass. And out of 835 cows, 15 was killed by lion if there is no sign here. This is because there is something that hindered the lion's recognition of a cow as a cow. This also happened in communication. Some information has been sent and something prevent it from being recognized correctly. Let's look at the following example. This is an RFID system. They attach a transcoder or tag on object and read it with an RFID reader. An electromagnetic field is formed between the transcoder and the reader, and the information in the tag is transmitted to the reader. If power is given here, a signal is generated and the binary data can be transmitted. But how much data will be delivered? We want to convey as more data as possible. What are the factors that determine the limit of the information delivered? What we want to know in this class is the amount of information these systems can convey. EEG is one of the measurement systems used in hospital. EEG is recording electrical activity uh, from the skin uh, about inside the human body. What we want to know is what's wrong with our inside body. To know this, we measure electricity flowing inside humans from the outside. With this, cancer in the brain or abnormal symptoms of the heart can be detected. But sometimes they make a mistake. This is because information transmitted to the doctor from the abnormal area is incomplete. What can we do to make more accurate diagnosis? We could succeed in accurate diagnosis, but will it harm the patient's safety? In order to answer these questions, quantitative analysis is required. In this picture, two girls are playing a game. Their headphones are very loud, and one person has to convey a short sentence to another. This game is fun because the listener listens wrong. It is difficult to convey even 10 words in a given minute or so. This shows an important principle of communication. If the noise is severe, the amount of transmitted information decreases. The same is true for RFID. Information written in the transcoder change the electromagnetic field, and a lot of noise enters the process of reading the changes in the reader. If there is no noise, RFID can transmit a lot of information. The same is true for EEG. The current flowing inside the human body flows precisely for a certain phenomenon, but when it is measured by a detector attached to the skin, various other information is mixed, and therefore accurate information is not transmitted. Let me explain this with a simpler model. In the system shown in the figure, there is a wall in the middle and a battery or voltage source on the left and the light bulb on the right. When binary data 1 comes in, the switch is on, and when binary data 0 is come in, it is off. Accordingly, light bulb can be turned on or off to transmit binary data. How can I pass more data in this system? First, the period of turning the switch on and off could be shortened. If you do once every second, you can transmit 1 bit per second. This is 1 bps. If you do 1,000 times per second, you can transmit 1,000 bits per second. This is 1 kilo bps. If you do it faster, the time it takes for the bulb to brighten up, and the time it takes for the light to go from on to off will be an issue. Another way to speed up data transfer is transfer multiple bits at once. For example, let's say in this figure there are four possible voltage levels. If so, the light bulb will have four brightness accordingly. 2 bits of information can be delivered at a time with four levels. Then, when the switching cycle is the same, the transmission rate will be doubled. If so, if you make 8 voltage level, it is tripled because 3 bits can be transmitted at a time. Then, by increasing the voltage level infinitely, we come to the conclusion that infinitely much information can be transmitted. But in reality, you will not be able to increase the number of levels infinitely. Why not? First, you cannot build a system that can withstand infinitely high voltage. Second, if the peak voltage is fixed, it has to be divided into innumerable small levels, so infinite number of levels, because in that case, the gap between adjacent levels will become narrower and narrower. The gap may be narrowed and the receiving side may not be able to recognize the difference. In conclusion, we cannot increase the bitrate infinitely for two reasons. First, the switching period cannot be infinitely shortened. Second, the voltage level cannot be divided infinitely. The decisive reason is that noise comes in during transmission. Remember, the game Two Girls in Headphone plays. If there is noise, the transmission speed cannot be increased. In other words, the more noise there is, the lower the transmission speed. If there is no noise in the channel, when we send 0 and 1 separately with 0 and 5 volt, the receiving side also receive 0 and 5 volt respectively. In the case of random data, 0 and 1 appears with the same probability. So in the probability distribution, the probability of 0 will be 0.5 and the probability of 5 volt will be 0.5 in both receiver side and sender side. If there is noise, the situation is different. The received signal will not be 0 or 5 volt anymore. It is different because random values are added or subtracted in the middle. As transmitting side, the probability of 0 and 5 volt are 0.5 respectively, but at the receiving side, the probability spread around 0 volt and 5 volt. If you transmit 0 volt, it can become 2 volt by adding 2 volt, or it can be minus 1 volt by subtracting 1 volt when you transmit 0 volt. If you transmit 5 volt, but 1 volt can be added to make 6 volt, or 1 volt subtracted to make 4 volt. If so, how will the receiver judge it? Usually, it is judged by whether it exceeds the intermediate value of 2.5 volt. If it exceeds 2.5 volt, it is judged that binary data or 1 was transmitted. And if it is less than 2.5 volt, it is judged that the binary data 0 was transmitted. If binary data is 0, so 0 volt is transmitted, but when it happens to, if noise was 3 volt, it adds 3 volt. Since it exceeds the judgment standard of 2.5 volt, the receiving side has no choice but to judge it as binary data 1. So this is called error. To be precise, it is a bit error. The probability of error increases as the area where the two probability distribution overlap at the receiving side increase. How to reduce bit error? First, the noise distribution can be narrowed. Then the overlapping area in the probability distribution on the receiving side could be reduced. Second way is to make voltage difference between two symbols make larger. Even if the noise distribution is same, the area where two probability distribution overlap will be reduced if the voltage becomes, for example, from 5 volt to 10 volt. Then overlapping area will be reduced and the error bit rate will be reduced.